Okay, for FRQ7, so for 7A, draw the free body diagram. This is the block, and so we have force of Fg, we're trying to pull it down, and then the slope is here. So perpendicular to the slope is our Fn. And then for our A will be going in a loop like this. So A will be going around the cone, which is going to be following the path of this block right here. Next up, 7B. So first off, I'm going to write the net force in the horizontal direction, which is going to be equal to my Fc. And that is just going to be equal to F and the F at normal force, the horizontal normal force. And then I'm also going to write the net force of Fy, which is just going to be the normal force of F and Y minus Fg, because Fg is trying to pull it down right here, and F and Y is trying to pull it up so it doesn't fall down. So I know this is going to cancel out to 0 because it's not going to move up or down. And so I can expand this to Fn sine theta, because my theta is going to be right here. So then my sine theta will be this, minus mg. I can move mg to the other side. It's equal to Fn sine theta. And then I isolate for Fn, so mg over sine theta equal Fn. This will be my Fn. Then I go over here. So I could write my Fc is equal to Fn of cosine theta. Because if this is sine, this is going to be cosine because it's the other component. Now I can expand Fn. I could plug in Fn with mg over sine theta. And this is multiplied cosine theta. So my Fc in this scenario is just mg is simplified to cotan theta. And this will be my Fc. 7C, I could write Fc is equal to Fn of x. I'm not using the previous one because that's using g, which is not what the question needs in it. So I have Fc, I can expand this out to mv squared over r, which equals Fn cos theta. Now this r right here, so we can take tan theta that we're given. This will be equal to r over h. And then we could isolate for r. So now we have h tan theta is equal to r. So now I can replace this r right here with an h tan theta, like so. And then this will become, this is Fn cos theta. Now after that, I can isolate for cos theta here, Fn right here. So we have mv squared over r over h tan theta times cosine theta is equal to Fn. I can simplify this here. This tan theta is actually a sine theta or cosine theta. So that means this cosine thetas cancel out. So when I can simplify it, I have mv squared over h sine theta is equal to my Fn. For Fc, in 7C, so I can say net force of Fx, which is just equal to Fc, but I can also say that Fc in this scenario is just equal to Fn of x. My net force in the y direction is equal to my Fn y minus my mg, because mg is trying to pull it down, but Fny is trying to pull it back up. I know this one is going to cancel out, so then it won't move up or down, so then this is just equal to 0. Now I can move this mg over to here, and I can expand this Fn y as Fn sine theta, given the angle we're given. And then I can isolate for Fn here, so mg over sine theta would just be equal to my Fn. Then we can go over here. So since we're just looking for Fc, I'm gonna leave Fc as is, but this Fn x is gonna become Fn cosine theta, as so. Now my Fc, so I could plug this in, so mg times cos theta over sine theta is equal to FC. I simplify this to just mg cotan theta is my FC. For 7D, I can expand this FC as mv squared over r is equal to mg cotan theta. Now, this r can be rewritten as just h tan theta, as previously stated, is equal to mg cotan theta. So now I can move this over. So then my v, so this m cancels out and this moves to the top. So v squared is equal to hg tan theta multiplied by cotan theta. These two are inverses of each other. So in this case, v squared is equal to hg. I can square root this, so that v is equal to square root of hg. That'll be my answer. 7E, I'm trying to find the max velocity. So I'm going to write out my system. So net force of fx in this scenario is equal to fc again, but this is now equal to fnx plus fsx. As when we look at fs in this scenario, it's trying to push it down so that the car doesn't go all the way up. And then on the other side, for my other component, net force fy, I'm just gonna write that equal to fny minus fsy, because it's trying to push it down, minus fg. So this is gonna be equal to 0 because we're trying to prevent it from actually moving up. So then I'm gonna rewrite this as fn sine theta, as stated earlier, minus fs cos theta minus mg. And then this, we could expand. So I'm going to move this mg over to here to get fn sine theta minus f as cos theta. I can now expand this fs here so that it could be equal to fn mu as fn sine theta minus fn mu as cos theta is equal to mg. I can factor out an fn, so I can have now sine theta minus mu as cos theta. And then now I'm going to isolate for fn. So my fn now is equal to sine theta minus mu as cos theta equal to fn. So I'm going to move this over to here now. So now we have fc. So fc we can rewrite as mv squared over r is equal to fn cos theta plus fs sine theta. So now what I could do here is expand fs right here to be mv, so I have mv squared over r is equal to fn cos theta plus fn mu s sine theta. I can factor out mu of fn here, r equal to fn time open parenthesis cos theta plus mu s sine theta. Now I'm gonna isolate for this v right here. First I'm gonna make sure I'm gonna put max to ensure that it shows max. And so this I'm gonna multiply by r and divide by m. So v max squared is equal to fn r over m, and this is all multiplied by cos theta plus mu s sine theta. I can expand this fn right here to be what we had earlier over here. So it's mg over sine theta minus mu s cos theta. It is times r, and this r is times m, and this top here is multiplied by cos theta plus mu s sine of theta. Now after this I can cancel my m's, so I have v max squared is equal to r cos theta plus mu s sine theta over sine theta minus mu s cos theta. And then I can just square root from here. Oh yeah, g right here. Now I can square root this. And so my Vmax is equal to the square root of gr cos theta plus mu s sine theta all over sine theta minus mu s cos theta. And this is my Vmax. Now for min, it's similar. So first I can write my net forces again. Net force of Fx equal to Fc, which is equal to Fnx, but instead of plus Fsx, it will be minus Fsx, because we're trying to push it upslope. And if we're pushing it upslope, then what happens is that it's going to be pushing away from the center, the horizontal part. Now for the net force in the y direction, I could write this as Fny minus plus Fsy, because we're pushing upslope, minus mg. Again, this is going to equal to 0 again. I can expand Fny as Fn sine theta plus this Fs we said earlier was Fn mu s. So this Fn mu s, this angle is going to be a cosine theta minus mg. This mg here represents fg of the block, the object. Then I can move mg to the other side. Now I can factor out Fn from these two terms. I have Fn times sine of theta plus mu s cos theta. And I could isolate for Fn by dividing by this term right here, coefficient right here. So mg over sine theta plus mu s cos theta is equal to my Fn. Now for this one, I could expand my Fc again as mv squared over r, which is equal to my Fn cos theta. This is going to be a sine theta for the, but then I'm going to expand Fs as Fn mu s, and this is x, the horizontal component. So in this scenario, it will be a sine theta, because this one's cosine theta. And then I could factor out an Fn again, so I'm going to move it down here. So you have mv squared over r is equal to Fn times cos theta minus mu s sine theta. Then I can do a similar thing again. So I'm going to move the r and the m to the other side by multiplying by r and dividing by m. So I have v squared is equal to Fn r times cos theta minus mu s sine theta all over m. I expand this Fn, I could substitute as Fn with mg over sine theta plus mu s cosine theta. So we have v squared. Alright, I'm going to put this as min to be safe. And then so his Fn here is going to be, so mg r cos theta from before minus mu s sine theta over m times this denominator here, so it's sine of theta plus mu s cos theta. These m's cancel out, so my v min squared is equal to gr times cos theta minus mu s sine theta over well, there's no m anymore, over sine theta plus mu s cos theta. I can square root this, and my final answer for v min is, which is going to be equal to gr times cos theta minus mu s sine theta over sine theta plus mu s cosine of theta. And that will be my v min formula. For 7g, we're trying to find fnet, so I'm going to write fnet squared is equal to its component, so fx squared plus net force of fy squared. Now, in this scenario, since it's not going to be moving up or down, this Fy squared, Fy, net force Fy is going to be equal to 0. So we could cancel this out. So we're left here with net force of F, so it's F net squared is equal to net force of Fx squared. So I'm going to write net force of F net is equal to net force of Fx. Now, what I'm going to do here is expand F net force Fx, which is just mv squared over r, because we have it's equal to Fc. And then so that means my net force of the whole entire system is equal to mv squared over r. And after this, I'm going to use my Vmax formula from before and plug into V here. That means my net force is equal to m times the square root, let's see, square root of, let me make this bigger. So m times square root of gr times cos theta plus mu s sine theta. And this is all over sine theta minus mu s cos theta. This is my, and this is all going to be squared. It's all over r. Now we have net force here, so this square cancels out. So we have net force is equal to m gr cos theta plus mu sine theta all over r times sine theta minus mu s cos theta. And now I'm going back here. If you notice here is there's an r on top here and r on the bottom here, so we can cancel them out. So all we're left with here is just net force equal to mg times cos theta plus mu s sine theta over sine theta minus mu s cos theta, as we did here before. Now, to get this to be 1 and this, the cotangent this to be 1 and all that, we're going to have to divide the numerator and the denominator respectively by 1 over by just sine theta. So if we could do that, this will distribute to here, and this will distribute to here, and this will distribute to each of these terms right here. So you have net force is equal to mg, and this will go here, so it'll be cosine over sine is cotan theta plus mu s sine over sine is just 1 over sine over sine, which is 1, minus mu s cos theta over sine, that's just cotan theta. And this is also multiplied by mu s. And this is the form, this is what I got for my formula, and this is how you find net force.